Hello everyone, welcome to my YouTube lecture channel. So here today we'll discuss on parallelogram law. So this basically parallelogram law of forces comes in the addition of vector. So if myself Anima Ghosh, Associate Professor Physics. So if why this parallelogram law of force where is used? So if let's say that two people pull a box in different direction, then how we can find out the total force acting on it? In our daily life, that force act in different directions, velocity combined in different direction, displacement combined in different direction. So we need a method that to add a vector graphically and mathematically. So the method is called the parallelogram law of force. So just for a quick revision that we know what is a vector. A vector is a quantity. The vector is a quantity. We know that vector, it is a quantity which have the magnitude and as well as direction. Example, let's say example is force, velocity, acceleration, displacement, momentum, etc. So vector generally give the notation as, let's say this is a vector A, then this arrow mark is indicating the direction of that vector. So magnitude we generally define as within the mode. For example, that also we have another quantity, physical quantity like scalar. So scalar is a quantity which have only the magnitude, no direction. Let's say mass. And vector which have magnitude plus direction, that is the vector. So now coming to parallelogram law of force, which is today's topics to discuss. So if two vector acting at a point, so let's say this is a vector A and this is another vector B acting from a same point, let's this point O. So if both the vector represents in magnitude and direction by two adjacent side of a parallelogram, then the resultant is represented by the diagonal through that point. So let us complete this parallelogram. So if we complete it, and then it is the diagonal, so this will be the resultant uh, vector, or we can if we say that two force A and B, then the resultant force will be represented by here the R. So this magnitude of the vector A is, we may write the magnitude, this is a vector and this is a vector. So magnitude of vector A, so this is written as A, and the magnitude of vector B, so that we can write as V. And if the angle between them is theta, then we can find out easily the resultant of these two vector. So now let us do the statement that if two force acting at a point are present in magnitude and direction, that means the both the force should have the magnitude and direction, and they are representing by two adjacent side of a. So our two vector, like let's say this and this, so both are working from same point. This is A and this is this direction, this is the V. So now that, and the angle between them is theta. So now if they complete a parallelogram, so let's say this is our parallelogram and this will be the resultant vector. This is our B vector, this is our A vector, and so if this angle is the theta and this angle is alpha. So now that what will be the value of this resultant vector, so in the chat box I will give the details description and mathematical analysis of this. So basically the resultant of this vector can be find out as that r is equal to this vector is basically a vector is a square plus b square plus 2ab cos theta. So this is the resultant vector magnitude of this parallelogram law. And now if the angle alpha is one of the vector with the resultant r, this alpha we can define as in between b and r. So the direction we can find out by the formula tan alpha is equal to b sin theta divided by a plus b cos theta. Now if this angle alpha is in between b and r, then we can write this formula as a sin theta plus b plus a cos theta. So this is the representation of resultant vector of parallelogram law. So now there is some consequence, there is some special case that when this theta value is this theta is both the vector is in same line, straight line, or they are in a angle of 180 or 90, what will be the cases. So now let's see that the first case we will be discussing, that if theta is equal to 0 degree, then the resultant will be r is equal to p plus q, because our formula is rc is equal to our formula r, that is basically equal to a square, repeating this one, r is equal to a plus b, sorry, a square plus b square plus 2ab cos theta. So theta is 0, that means this part, so we can get 1, so a plus b whole square, that means r is equal to a plus b. So that means if this is one vector a and then another vector, if is the same direction, then the resultant will be this r. This is, let's say, b and this is a. Now second situation, if the theta is equal to 180, then resultant we can get r is equal to a minus b, because cos theta here we will get the minus 1. So then this r is equal to a plus b means here we can say that both the vector are collinear and are in same direction. So r is equal to a minus b, that means here we can say both the vector are collinear but they are in opposite direction. So here a and b are opposite direction and here both are a and b are in same direction. So the third situation, if theta is equal to 90 degree, then we can find r is equal to a square plus b square. This means that both a and b vector, let's say this is our a and sorry. So if this is a vector and this is another one, this is A and this is our B, then the resultant will be in this. So both the vector are perpendicular to each other. So if we summarize now that parallelogram law, that it is a very simple and essential law used to add two vectors in together and the mathematical formula. So this can be used to solve two co-current forces acting at the point, and this law is state that the forces are represented in magnitude and direction by two adjacent vectors of a parallelogram. Then the resultant can be find out from the diagonal of the parallelogram starting from the same point. So the key takeaway from here, these vectors cannot be added algebraically, use geometrically by additions. Parallelogram law works by an angle. Special cases are simplify the formula. So I hope this will be helpful to simplify and to understand the concept of the parallelogram law. So thank you very much for watching the video. If you like the video, please click the like button. Thank you.